Hey everyone, I've just finished building this gasifier and charcoal retort, and I'm in the middle of the first test burn. I'm really interested in alternative energy, and I love the idea of being able to go fully off-grid with home-sourced electricity. That's why wood gas and gasification is one of the more interesting subjects to me. If you're living off the land, you can source your own fuel and convert it to electricity. I've been designing this project in my head for years, and I'm doing it a little bit differently than I've seen before, so let me walk you through the theory, and then we'll get into the build and how I made it. But before we get too deep into it, I really want to thank VITCAS for sponsoring this video. They make really good fire-resistant products for things like kilns, forges, or charcoal retorts. And I'm stoked to be collaborating with them because I've been using their products for years for my own projects. I love to be able to recommend to you guys products that I really believe in and have a lot of experience with, and VITCAS fits that bill perfectly. And then later in the video, I'll show you the specific VITCAS products I used for this build. Okay, let's get into the theory. So I look at this as two distinct phases. Initially, there's a pyrolysis phase where you're making charcoal, and then the second phase is gasification, where you're turning the charcoal into syngas, which is clean enough to be used in engines and not gum them up. When you see a typical fire, like in a wood stove or a campfire, the flames that you see are actually the syngas burning off. And syngas is largely composed of carbon monoxide, hydrogen, and a little bit of methane. And if you can get that gas clean enough, it's great to run gasoline engines with. But that's the trick, it's gotta be clean enough. And if you try to skip pyrolysis and go straight to gasification with wood products like firewood or wood pellets, it's really difficult to get clean enough gas. It can be done, but it generally requires much higher temperatures and pressures than are easy to achieve in a DIY setup, which is why I designed this system to be able to do both processes. So the first step is pyrolysis, which is burning wood to make charcoal, and you're burning the wood in a low oxygen environment. So the barrel inside that has the feedstock or charcoal wood inside of it is sealed off, and it's actually heated from the outside. At the beginning of the process, I build a fire underneath the barrel and close the system up, and that will begin to heat the system and cook the wood on the inside. As that temperature begins to increase, first it'll drive off a lot of the moisture, and it'll often kind of hover at a lower temperature as the water is being cooked off. And then you might see a rapid increase in temperature, which generally means you've driven off most of the moisture, and then you'll be starting to drive off some of the volatiles. But it'll usually be a really heavy, dense smoke, and it's not yet flammable. But once you keep that burn going, eventually you'll be producing enough syngas that it's actually flammable, and you can light the flare stack. Once you can light that on fire and you know the syngas is now flammable, you can begin piping it back into the retort to continue its own burn, so you don't have to maintain the fire below, and the syngas itself will maintain the rest of the burn for the charcoal making process. After that, you just need to let the barrel completely cool off before you open it, or in a system like this that's designed to do both phases, you can roll right into the gasification. So then in the gasification phase, you're burning the fuel, but this time with a little bit of oxygen or steam. It's generally about 1/3 of the oxygen that a fire would consume in an open environment, and even better, if you replace that air with steam, you'll be getting a more energy-dense syngas because you'll be adding a lot of hydrogen to the mix. And once the gasification is up and running, you should be producing much cleaner syngas than you did in the pyrolysis phase. Next, you would send that syngas onto some cleaning devices to further clean it, and then you could either store it, burn it, or run an engine with it. And that's the basic theory. Now, I've never seen a DIY system designed to do both pyrolysis and gasification, so there might be a few kinks to work out along the way, but I'll cover any mods I make in future videos, and I'll do a follow-up video where I get into how to clean the gas, potential ways to store it, and how to modify an engine to run really well on it. Please remember, likes and subscribes really help the channel grow so we can keep the content coming. If you have any questions, comments, or suggestions on how to make this better, throw them down below. I love to see the comments. And if you want to help us directly, you can do that over on Patreon, where you get bonus content and behind-the-scene videos. I'll run through the basics of the design, and then I'll show you how I built it so you can really understand how it's working. The main body of the retort has 3 inches of insulation, and any exposed metal on the inside is going to degrade really quickly because of the high temperatures. So all of the exposed metal on the inside is made to be easily replaceable. That should increase the life of the system by a huge margin. Inside the retort is the sealable barrel with 2 separate pipe systems. The first one you can see here comes off of the barrel and down here, and then I can direct it either back into the retort to facilitate the burn phase, or onto here. You can see I'm flaring off some of the excess gas right now, but in a later phase of the build, this will go on to some cleaning devices and then onto a motor to run a generator. The second pipe system comes in here and goes back into the barrel, and this is how I can add either air or steam for the gasification phase. The flue comes out of the back at the bottom, and inside the retort there's a heat partition wall here, so it forces the gases to swirl up over the wall and back down in. So it's creating a sort of heat bell or heat dome effect. So hopefully I can keep much higher temperatures in here without losing most of it right out the flue. And then there's an Arduino system that I built and programmed from scratch, and this allows for you to set it up and be able to walk away without maintaining and monitoring the system through the burn. I'll just give you a quick walkthrough of the Arduino system. So it's built completely from scratch and then just mounted in this box. And it's hooked up to a motor here in the back, which controls the damper in the flue system and then is protected by some heat shields. And it's also taking a flue temperature reading and a syngas temperature reading. And I wanted the whole system to run off grid, so it just runs off a Dewalt battery. Then there's an on switch and it'll power up. The system has a timer. It's monitoring the flue temperature and the syngas temperature. It also has a manual mode and an automatic mode. In the manual mode, I can adjust the damper position via these buttons here. And then in auto mode, it's going to automatically adjust the damper position to try to hit the flue target temperature, which I can adjust over here. I can raise and lower that as much as I want. It's also got a setting that'll tell me to add fuel if it senses that I'm running low on the initial startup fire. And then it also has a calibration mode where I can calibrate the damper motor. It also has an overtemp protection, so I've got that set at 1200 C right now, and if it hits that, it fully closes the damper off and it will alert me that that happened. So that's the basics of how it works. Now let's get into the build. I'll start by marking out the main pieces and getting them cut. This is the bottom grate with the air inlet, and then this second piece just sits right on top of it, and you can adjust the air intake by sliding this back and forth, and it will also serve to help clean the ash out after a burn. With all the pieces for the main chamber cut out, I can start to get that assembled. First I'll get the bottom grate welded up. Now I'll weld the fire grate together while I can get to it easily. And this is designed to be replaceable. Now that this is done, I can add it to the main body. Now I'll get the main chamber tacked up. Now I'll dial in the shape with some clamps, and then I'll trim the edge in some flat bar, which will add rigidity, but also help keep the internal lining in place. Now I'll add some legs so I can get it up off the ground and work on the rest of it easier. To make the back panel, I've traced this exact shape just directly onto the sheet so I can cut that out and it'll fit perfectly. Now I'll weld on a rim so the end piece acts like a cap. Next I'll make some removable cradles that support the barrel and sit in here. So I'll use some flat bar and bend that round. So that'll get welded together, and then I can just pull them in and out and replace them when needed. Now I'll cut some holes for pipework that I'll add later on. Now I'll cut a hole in the back and weld on a flange so that I can attach the flue later on. Now this is ready to start lining the inside with insulation, and that's going to do two things. One, it's going to make the burn more efficient by just insulating it and keeping more heat in, but it's also going to cover the exposed steel on the inside, which is going to protect it from oxidation so it'll last a lot longer. If the steel was just touching the open atmosphere in there, it would start to degrade really quickly and the whole thing wouldn't last very long. So to do this, I'm going to be using two VITCAS products. These things are really awesome. First is this ceramic fiber board. It's big sheets about 1 inch thick. You can cut it really easily into any shape you want and it'll lie right against these flat surfaces. It's temperature resistant up to 1430 C, and that's even before you put an additional coating on it that'll boost that even higher. And this stuff's really good for lining things like kilns and forges and furnaces. It's just great all around stuff. And then this is just a ceramic fiber adhesive, and this works with the board and ceramic fiber blankets, all sorts of insulation materials, and this will bond it to things like steel and masonry. And this is also suitable up to 1450 C. So together, these two things will create a really nice first layer of insulation. Next, I'll line the back cap with insulation board. Be careful when you work with this stuff. You don't want to breathe the tiny fibers of the ceramic fiber insulation. So mask up, and as soon as you're done, wash off and change clothes. This end cap is also designed to hold the heat partition wall in place. I'll paint any of the exposed surfaces of the ceramic fiberboard with this VITCAS zircon paint. It increases the exposed surface temperature levels to 1750 C. Just a 1 or 2 millimeter coating will extend the life of the fiberboard by up to 4 or 5 times, and it seals up all the cracks and locks in all the tiny ceramic fibers. I've let the paint dry overnight, so now I can place the heat wall into the back cap and then install the whole back cap assembly onto the back of the retort. So now the back's attached and it's welded at about 8 points. I could get back in pretty easily. The only reason I'd need to get back in here is to replace that heat dividing wall. So if I went beyond the prototyping stage, I might replace the welds with some kind of bolt-on mechanism, but I'll probably never have to go back in there. And here it is from the inside, and you can see this baffle wall here, and the gases will have to flow up over that and then back down and up out the flue. Now the whole thing gets 2 inches of this VITCAS ceramic fiber insulation blanket, which will really help boost temps and improve overall efficiency. You might have seen this product before in my wood stove water heater videos. Then the whole thing gets a sheet metal shell. Now I can start adding the syngas piping system, and I'll start by extending the holes through the outer shell. Now I'll drill holes in the barrel to fit the pipework. I'll make a custom flange to fit the curvature of the barrel. I'll line up the first piece of pipe and its flange with the holes and get it tacked together. Now I can line up the flanges with the pipe holes so I can drill some bolt holes for mounting the flanges. Add a second flange to the inside and bolt them together. Before I tighten the nuts all the way down, I'll add some fire rope around the edges to seal it. I'll do the same thing to the other flange. A few of the pipes need a little prep work before I assemble the whole pipe system. I'll add some holes to these pipes, and these are the air inlets for the gasification, so it should be able to flow freely and evenly distribute the air. I need to add a socket onto the next pipe to add a pressure relief valve. And the last pipe I need to cap off and add some holes so that it can act like a burner. Now I can fully install the pipe system. Here the syngas can either be diverted back into the retort to assist in burning or onto cleaners and either storage or use in an engine. A T connects to the smaller flange in here, and then each one of these gets a cap on one end and then screwed into the T. When the retort's being used for gasification and the charcoal inside needs some air or steam to facilitate syngas production, it'll enter here, and then it comes through the T, which splits it and distributes it evenly through the barrel. Next I'll work on the doors, and I think I'm going to do a 2-door system, and they'll split across the middle right about here, so that if I need to add fuel during the initial burn phase, I can open this bottom door and to have access to that while leaving this top door closed so that most of the heat still remains captured in the sort of top heat bell. The first thing I'll do is just trace out the front here so that the door fits precisely. Now I'll cut the insulation to the right shape to add to the door. I'll add a rim around the main sheet of the door. Then I can drop in the insulation and add some edging to hold it in place. Both door panels are done and ready to install now, but first I want to install the fire rope because that'll help positioning for the installation. And this fire rope is another VITCAS product. I'll weight it down a little bit to dry overnight and come back and install these tomorrow. I'll put the doors in place, then weld on some hinges with removable pins so that I can easily pull the doors off. And then add some latching mechanisms that'll also help support the door on the other side. I'll probably add a second layer of fire rope around the inner layer of the retort to make sure the doors are double sealed. And here are the completed latching mechanisms. Now I'll start on the custom damper system. I'm just going to add the damper to a section of flue pipe I already have, and I've just got a scrap circle that I can cut it out of. Now I'll weld it in place. Now I'll attach the flue pipe with the damper and some heat shields so I can install the motor and Arduino control box. All right, we're up and running. Just about ready for testing in the morning. The last thing I need to do is give the insulation board on the inside of the doors a coat of the zircon paint, let that dry overnight, and then tomorrow morning we'll fire it up. It's all ready to go. I've got the charcoal wood loaded up in the barrel, and there's a fire ready to go underneath it. I just need to seal off the barrel. I'll just be using the barrel lid, and I've replaced the rubber gasket with fire rope in here. So that's all sealed up. I just need to start the fire and start the Arduino system. All right, we've got a nice draw at the top. Okay, so it's started up nicely. I'll just let it settle into its burn and check back with you in a minute. So we're only 8 minutes in and the fire's burning clean because the smoke coming out of the stack is almost clear. And we've got 362 centigrade inside the retort, and the gas coming out is 42 degrees Celsius. But so far it's looking really good. So we're about 15 minutes in and we've got about 500 Celsius in the retort and about 300 Celsius coming out at the syngas. Now we're a bit too cool to be producing really clean, usable syngas. We want to get that up to about 400 degrees. So we're about 20-25 minutes in and we're about 600 degrees in the retort. We're just about to hit 400 degrees on the syngas, and we're really starting to produce a lot of smoke. And as soon as we see that start to clear up, we'll be getting to the next phase, and I'll check back with you then. Okay, so this smoke is looking pretty good, and it should be ready. And there we go. So now that we know that the smoke is burning well, I can start feeding it back into the retort. Okay, and so I'll turn on the gas, and there we go. That is going to be a self-sustaining cycle. The syngas flame is starting to die out, so we know we're almost done with the charcoal making cycle. And as soon as it goes away completely, I'll shut the whole system down. Okay, it's all finished, so now I'll shut it down and wait for it to cool off. While I'm waiting for it to cool off, I'm going to give the whole thing a coat of paint, and I'll be using this VITCAS high heat paint. It's really good stuff. It's good up to 1470 Fahrenheit, 800 C. Okay, it's been sitting for about 18 hours, so I'm about to crack it open and see what kind of charcoal we made. But I'll also mention that if it hasn't fully cooled down, the charcoal can reignite when you open it up. So you definitely want to make sure that it's fully cooled down before cracking it open. All right, let's check it out. And that is some great looking charcoal. It's fully carbonized. You can see it's maintained its original shape, and this is all ready for processing down. I'll sift it and sort it out by size, and then we'll move on to the next phase. Okay, so the whole system looks like it's working really well. There's a couple little things I'm gonna do, and I didn't use the best quality wood for this initial test. So in the next test, I'll step it up to use some nice hardwood and to make really nice charcoal. And then I'll be back soon with the second installment of the series where I get into extracting things from the gas like tar and wood vinegar, and then cleaning the gas up and sending it on to store it and use it in an engine. So that's it for now. I hope you enjoyed the video. I really enjoyed building this one, and I can't wait to see where it goes. So take care and see you soon.